The last thing that we're going to look at this semester is inverse normal curve application problems. So just like how with the regular normal curve problems, first we did them just using z-scores and then we moved on to applications. Now we can also move on to doing these inverse normal curve problems for normal distributions where the mean and standard deviation aren't 0 and 1. It's pretty much the same idea as what we were doing before. The only thing is, if you're working from the tables, there's an extra step now where you're going to have to convert whatever z-score you get as an answer back into some type of value that's relevant to the problem. If the problem is about exam scores, they don't want a z-score back, they want whatever grade is on the exam. Or if it's talking about an amount of money, the answer isn't going to be a z-score, it's going to be some dollar amount having to do with the problem. So we'll start this by looking at some example, and then we'll go how to do it. This is the only extra step. On the calculator, it's pretty much the same as how you would do it before. You just need to know what your mean standard deviation is, the value the problem's asking you, and the area to whatever the left of that value is. Okay, so here first, let's suppose grades on a history exam are approximately normally distributed with a mean of 70 and standard deviation of 9.5. First, they're asking us what grade is higher than 97.13% of all grades. So what we're going to do here, again, first draw a picture. Always draw a picture first. So we started setting up our curve. Now they're asking us for a grade that's higher than 97.13% of grades. That's more than half. This is the lower half of the curve, and that's the upper half of the curve. So if we're looking at more than 50% of the grades, right, and 97 is higher than 50%, that tells us whatever value we're looking for is going to fall somewhere here. And this 97.13% is over here. So the fact that it's higher than more than 50% is important, and that's why our drawing is going to look like this. So we know this piece is 0.5, and if we want to find the area of this piece that we can look up in the tables over here, that's going to be 0.9713 minus 0.5, which gives us 0.4713. And this is what we look up on the table. We're looking for 0.4713. Okay, 0.47327. Okay, here exactly. 0.4713 tells us z is equal to 1.9. However, 1.9 is not the answer that we're looking for. The average score on this exam is 70. 1.9 is definitely below what the mean is. So it would not make sense for this answer to fall here. If our mean is in the middle, 70, whatever this score is definitely is going to be higher than 70 if it's higher than 97.13% of the grades. So what we need to do now is, remember we had this formula over here for changing values into z-scores. We're going to need to use this formula to take the z-score that we have, in this case 1.9, and change it back into a value relevant to the problem. So you can use the same formula we've been using. It's a little bit more algebra. This is the same thing. It'll get you the same answer if you don't mind working with more formulas and want to get your answer outright, but I'll use this one for now. So, here we have z is equal to x minus the mean over the standard deviation. So here we have 1.9 is equal to x, and this x is going to be our answer, minus 70 over 9.5. We multiply both sides by 9.5, we get 18.05 equals x minus 70. Then we add 70 to both sides, and we get x is equal to 88.05. And now this makes sense. This makes sense because 88.05 is higher than the mean, so it would make sense that this score is higher than more than half of the grades. Now let's say that we wanted to do this on the calculator. It's not that much more difficult than the other problems we did before. We just have to be mindful of what numbers we're putting into the calculator. Now this is one of the easier ones to do on the calculator because they already gave us the area to the left. So we don't have any extra work to do to figure out what number we're going to be putting in the calculator. We are going to put in, we're going to go to inverse normal. We're going to put in 0.9713 for the area to the left of the number we don't know. Our mean is 70 and our standard deviation is 9.5. Then we hit enter, and the calculator is also going to give us a number that rounds to 88.05. It's going to be longer than this, but it ends up rounding to the same thing. So either way you chose to do this, you'd get the same answer. And on an exam, you could do it either way as long as you show all of your work. And all of your work is the picture and then whatever else you did. Whether it's exactly what you put into the calculator or whether it's the stuff you're doing over here and the values you got from the table. Now let's look at part B. What grade is higher than 34.46% of all grades? So now notice that these are worded similarly. So here we're higher than 97 and something percent. Here we're higher than 34 and something percent. So here we're higher than less than half of the grades, and that's going to influence how we draw our diagram. So since we're higher than less than 50%, we'll start drawing our picture. Our lower half of the curve is over here. So if we were to go right up to the mean, this is 50% exactly. And if this grade is higher than less than 50%, whatever this grade is has to fall below the mean. It has to fall somewhere here. We don't know what it is, but whatever it is, it's definitely going to be less than 70, which is what our mean is, and they're definitely giving us a piece of area like this. So we can do this on the calculator first, and then we'll do it using the tables. Right, they already gave us the amount of area to the left, so it's a little bit easier like that. So what we would input is inverse normal. Our area to the left is 0.3446. Our mean is 70. Standard deviation 9.5. We hit enter. We end up getting 66.2. So this would be our exam score over here. And again, this makes sense because 66.2 is less than 70. So it makes sense that that value would fall over here if it's higher than, 34%, which is less than half of the grades. Now, if we want to do this using the tables, there's a little bit more work, but it's still pretty much the same from what we were doing before. We know this over here is 0.3446. So if we want to find the area in here, which is what we can look up on the tables, we have to subtract this number from 0.5. So in here, this is 0.5 minus 0.3446, which is 0.1554. Now, this is the number that we're going to, let's put this off to the side. This is the number that we're going to look up on the table. We're going to look that up on the z-table, find a z-score, or the number closest thing we can find to 0.1554. And that ends up being right, it ends up being right here. So 0.40 gives us 0.1554 exactly. Now, some people may be tempted to do this, and this is a very common mistake when people are using the tables. We're using the table, we look up the value we get, and this table only gives us positive z-scores, but if we look at the picture we drew, we know that this should actually end up being a negative z-score because this value falls below the mean. So if we work with positive 0.4 and we go back to change our z-score to exam grades, our answer is not going to be right because we're going to be finding the equivalent value that's over here, not the value that falls below the mean. So we have to remember that this is negative because it's below the mean. And now that we've done this, it's pretty much the same thing that we did up here, where we're going to have to plug it into our z-score formula and then end up solving for the value. So this time, maybe we'll plug it into this one and we're going to end up with the same thing. So x is equal to, or in this case, our exam grade is equal to z, and our z this time is negative 0.40. Our standard deviation is 9.5, and our mean is 70. So now we go through and solve this. We end up getting negative 3.8 plus 70. And then we end up getting x is equal to 66.2, which is the same thing that we got before. So now we'll look at some other ones. Part C, what grade is lower than 84.85% of all grades? Now that they're using the word lower than, they're phrasing it differently. We have to figure out exactly where we're going to place the area that they're giving us. Now, if this grade is lower than more than half of the grades, this is the upper half and we're lower than more than half, that tells us our value is going to be falling somewhere over here, and it's lower than all of these scores. So if it was lower than just 50%, that would be the mean. The mean is lower than 50% and higher than 50%. This one is lower than more than 50%. So that's where our mystery grade goes. Now, if we wanted to solve this using the tables, we can do that. If we want to solve it using the calculator, we have an extra step to take because they're not just giving us what the area to the left is. We're going to have to figure that out on our own. If we're using the tables, well, we have to figure out this piece of area, look it up, find the z-score, then change the z-score back into an exam grade. We'll do this using the tables. We know this piece is 0.5, and then this piece in here is going to be equal to 0.85 minus 0.5, which gives us 0.3485. So this is the value that we would look up on the table because the table gives us pieces of area between the mean and some other value. So we go to our z-table and we try to find the closest thing that we possibly can to 0.3485. 0.34, that's right here, 0.3485. If we go over, it ends up being 1.0, and then if we go up, we end up getting 0.03. So 1.03. However, again, this score is below the mean, or this mystery value is below whatever the mean is. So our z-score, we have to remember to make it negative because of the way our picture looks. Now that we've done that, we can plug it into our formula over here, this one again. So we plug that in here, we solve all of that, and we end up getting x is equal to 60.215. Now let's say that we wanted to do this on the calculator. We could still do it, but we need to know what the area in this piece is because the calculator wants to know the area to the left. The area to the left over here in this section is going to be 1 minus the whole thing. And that ends up being 0.1515. Right, or maybe we'll draw another picture so this is a little bit more clear. So if this whole thing on this side is 0.8485, and we subtract this amount from 1, which is the total area underneath the curve, we're left with 0.1515. So now what we can put in our calculator, now that we know the area to the left, we can do this. So that's inverse normal, 0.1515. Our mean is 70. Our standard deviation is 9.5. We hit enter and we end up with 60 rounds to 21. Okay. So these are very close to each other. It doesn't matter, again, which method you use as long as you show all of your work. Now let's move on to the next one. What grade is lower than 19.49% of all grades? So now we're talking about a grade that's lower than less than half of the grades. So when we draw a picture, it's going to look different. If this grade is lower than less than half, that means the piece of area they're giving us is over here. So they're telling us it's lower than less than 50% of the grades. If it was lower than exactly 50% of the grades, that would be the mean, and then this is the upper 50%. But we're lower than 19.49%, so that means our value has to be somewhere over here. And then this piece of area is 0.1949. So if we want to use the tables, we have to figure out the amount of area that's in here, because that's what we can look up. So this piece of area in here is 0.5 minus 0.1949, which gives us 0.3051. So this is, we're going to look this up on the z-table. I'm going to look for that on the z-table or for the closest thing that we can possibly find to that value. We find it here exactly, 0.3051. We go over this way, 0.8. We go up 0.06, so here z is 0.86. And it's okay to leave this positive because we can see that this value, whatever it is going to be above the mean. So now we would just plug things into this formula. X equals z times the standard deviation plus the mean. We solve for this and we end up getting x is equal to 78.17. Again, this answer should make sense because this value is higher than the mean. We expected our value to be higher than the mean based on the picture we drew, and it's higher than the mean here. So now let's say we wanted to solve this using the calculator. We would do pretty much the same thing we did over here. If we subtract this area from 1.1949, we're going to be left with the area to the left over here, and then that's the number we can put in our calculator. And that number is 0.8051. So we would do inverse normal. We put all of this into our calculator, we hit enter, and then we end up getting the same thing, or a number that rounds to the same thing, which is 78.17. And if we wanted to, get just a picture of what we did over here to find this area, right? If this piece in here is 0.1949, the rest of the area here is 1 minus 0.1949. And now let's move on to one more problem. Between what two grades would you expect to find the middle 75.4% of grades? Now when they say between what two grades, that means we're going to have to give them two different answers. And middle 75.4%, that should also tell us whenever you're working with a middle percent, there's always going to be two answers. We start by drawing our picture. And we know that we're going to have two answers at the end. Now, because we're dealing with a middle percent, we know that one should be higher than the mean and one should be lower than the mean. So whatever our answers are, at the end, we would expect one to be higher than 70 and one to be lower than 70. Now we know this whole piece of area is 0.754. So the area of each of these two halves, right, because we can look up this half on the table, is 0.754 divided by 2, which is going to give us 0.377. This piece is 0.377, and this piece is 0.377. So we're going to look this value up on the z-table, or the closest thing to it that we can possibly find. So we're going to go over here, and we get 3.77 exactly. If we go over, we end up getting 1.1. We go up 0.06. So here, z is going to be equal to plus and minus 1.16. That's because we have to remember we have a positive and we have a negative over here because we're working with a middle chunk of area, so that's going to give us two z-scores back. A common mistake is a lot of times people will just put the positive one and forget to do the negative one and then only give one answer. So now we just have to change positive 1.16 and negative 1.16 into exam grades. So x is equal to 1.16 times the standard deviation plus the mean, and then we have x is equal to negative 1.16 times the standard deviation plus the mean. So we solve both of these and we end up getting, for the positive one, we get 81.02, and for the negative one, we ended up getting 58.98. So these are our two grades. This one would end up going here. And then 81.02 would end up going here. Now let's say that we wanted to do this in the calculator. Well, we actually have to break this into two problems because we need to find a way to get the higher value and we need to find a way to get the lower value. Personally, I think when you're working with a middle piece of area, it's a little bit easier to do this using the tables, but again, how you solve this is up to you. For the higher value, our drawing is going to look like this. So we know that it's over here. We've already done the work to find that this piece is 0.377, and we know this piece is 0.5, so our area to the left is equal to 0.5 plus 0.377, which is 0.877. So to get this value, oh yeah, this is shaded. To get this value, we're going to do inverse normal, 0.877, mean, standard deviation, and they end up giving us 81.02. It rounds the same way. And then for our lower value, our picture looks like this. Our mystery value is over here, and we need to know what this area is. We know that this piece is 0.377, so this piece is going to be 0.5 minus 0.377. And that gives us 0.123. So in our calculator, we'll put inverse normal, 0.123, our mean, our standard deviation, and the calculator ends up giving us 58.98, which is the same thing that we got for the first one.